Okay, welcome back to the shop. Today we're talking gaskets, and I had a couple of gaskets that I needed to make. So I had this manifold that I built, and there are mating spigots on the cylinder head on the other side. So I needed some nice silicone tubes to connect the two up. I found these really nice CNC machine clamps that are very thin and very compact. They're very thin in this direction too, and because I only had room, I was trying to keep everything as tight as possible, so I designed everything with just enough room to fit two of those clamps side by side. And they were relatively cheap. They were like, I was thinking about making them myself, but they were $8 US, $8.95 or something like that. Shipping wasn't bad. It wasn't worth my time. I was thinking, well, $36 US and another $20 shipping. It's just, geez, it's just easier just to order them. And they come with a real nice little stainless steel liner in them that covers up the joint. So I think those are going to work quite well. So I wanted to make these connecting tubes. So I bought a 12-inch length of 1.5 inch silicone, reinforced silicone rubber, and I wanted to cut them. I wanted them to be nice and square. Here's, you can buy some of them already cut to a specific length. This is 1.25 inches, I think, and they're obviously about 3 inches long or something. But they're really nicely square on the cuts and everything. They're very nicely done. So I was able to make a tool that I was able to cut, and mine turned out really nice. They're equally as square as the other ones, and so I 3D printed a tool holder, and I'll show you in detail how that worked. So I needed to make this gasket, and for 3 reasons. It goes between this face of the manifold and the face of the spigot, and it insulates the manifold from the cylinder head, both for vibration and for heat transfer, which was something I was trying to do, trying to keep the heat out of the manifold and keep the vibration out of the manifold, which holds the fuel injectors. And the other thing that it does is the inside diameter is nicely matched, and the outside diameter is nicely matched, but the inside diameter being matched, it provides a smoother airflow. If there was a gap in between them or something, then you've got poor airflow characteristics. All right, so I needed to make a rubber gasket that was like this. Well, like this, actually. So I needed a certain outside diameter and a certain inside diameter, and I needed something that was nice and round and evenly cut. I had 3D printed some pieces for mocking things up, but at some point in time I needed to actually make rubber parts. So I ordered a sheet of 1/8 inch Buna-Ann rubber, and this is the tool I made. So I took a piece of steel shafting and machined it down, and then made a sharp edge to the inside diameter that I needed, and then I took a shaft collar and turned it down to the diameter that gave me the outside diameter that I needed. So if I take that, I put it in the hydraulic press, and I just set myself up with the press. It's pretty easy. To just press that down. So I just cut the outside. There's the inside plug. And I just used a little tool here to get inside and pry that out. And there's my gasket, pretty much perfect. So I 3D printed this tool holder, and it fits into the dovetail holder that goes on my tool post. And then I just put a slot in it and a bolt in the middle. And then into that tool holder I just fit a razor knife. And so it just sits up against the silicone tube. I zeroed my lathe back at this face, and I went out to the length I wanted it. And then I just spin the lathe in reverse so that the rotation of the tube is away from the blade, not into the blade. And then I just put some pressure on the blade and it cuts. Once it's spinning, put some pressure on the blade. And there, it's cut through. So there's my part still on the mandrel. It's tight, it's hard to get it off. But you get it off and they're perfect. They're perfectly straight, they're perfectly clean, beautiful cut.